Today we are pleased to have representatives from the Texas Parks and Wildlife Department, the Virginia Department of Game and Inland Fisheries, and the Minnesota Department of Natural Resources to share their experiences with various Dreissena mussel control techniques, including methods and results, and to answer questions about their efforts. In just a few minutes, we will begin our first presentation. But before we begin, I have just a few logistical items to cover. Today's webinar will be recorded and posted on the Invasive Mussel Collaborative website within a few days. We are pleased to have more than 200 people registered for this webinar. Due to the large number of people participating, all attendees' lines are on mute. Attendees will remain muted throughout the webinar, and we will be taking only written questions. Thus, if you have a question, you may type it into the questions pane of your GoToWebinar control panel. Questions may be submitted at any time during the webinar. Depending on time, we may answer one or two questions following each presentation, but the majority of questions will be addressed after all three presentations have been given. We will do our best to take all questions or comments during the webinar. If you have to leave the webinar before we have gotten to your question, we encourage you to review the webinar recording that will be posted on our website to hear your question and answer at a later time. If you are experiencing technical difficulties, you may send a chat message directly to the Great Lakes Commission organizers for this webinar. So with that, it's my pleasure to introduce our first presenter this morning, Brian Van Zee. Brian started his career with Texas Parks and Wildlife in 1997. He has worked as a fisheries management biologist in the Wichita Falls, Canyon, and San Angelo district offices. He is currently stationed in Waco, Texas, serving as the Inland Fisheries Regional Director for the western and central portions of the state. He earned a Master's of Science degree from South Dakota State University in 1996. So, Brian, we will hand off presenter status to you, and you can get started.
Okay. Well, thank you, Eric. I appreciate that. Okay. Can everybody hear me? I'm assuming they can. Thank you, Erica, for that introduction. Again, I'm Brian Van Zee with Texas Parks and Wildlife Department. And today I'm going to be visiting with you all about the zebra mussel efforts that we've been conducting here at Lake Waco. If we have any questions afterwards, or if anybody wants to try and reach me after this webinar or at other times, again, I'd be happy to visit with anybody at that time. But let's go ahead and get started. Lake Waco is actually located completely entirely within the city limits of Waco. It is approximately an 8,400-acre U.S. Army Corps of Engineers reservoir, and it is the municipal water source for the city of Waco and as well as many surrounding communities. It provides water for roughly 200,000 citizens within the area. From a recreational perspective, it is estimated to provide anywhere from $20 to $40 million to the local economy annually, and it is a very productive and hyper-eutrophic system. Now, the zebra mussel story for Lake Waco actually kind of begins back in 2012. In 2012, the City of Waco, the Army Corps of Engineers, and Parks and Wildlife got together to discuss the threat of zebra mussels as they were beginning to develop and spread throughout the state of Texas. As a result of that meeting, the city developed an outreach and response plan for the Lake Waco. Now, the plan focused on prevention and detection, but also identified partnerships and actions that would be needed for a quick response should the lake become infested. Prevention efforts really focused on public awareness and implementing a boater inspection program which started back in 2013. Detection efforts included sediment samplers, monthly shoreline surveys, collecting plankton samples for microscopy analysis, and working with marine owners to regularly inspect their boats and docks. The response efforts identified possible treatment, mitigation approaches, and purchased equipment. This was especially in regards to the municipal water treatment plant, their intake structures, and the dam operating structures. The research was primarily focused on coordinating with Texas Parks and Wildlife Department and Baylor University to keep abreast of any new information or regarding early detection and control procedures that may have been developed or may have come available. Now, even with that plan in place and the efforts that we were doing to try to inform the public about the threat of zebra mussels, unfortunately, in September 26, 2014, zebra mussels were first documented by the City of Waco staff conducting their monthly shoreline surveys at a private country club's boat ramp. This was not a boat ramp where some of our boater inspectors had been working, because it was a private marina. Then in September 29 and 30th, 2014, Parks and Wildlife conducted additional surveys and collected plankton samples near the private marina, as well as around the lake and other marinas located on the reservoir. Zebra mussels, again, were only found on and adjacent to the private marina boat ramp, and no villagers or DNA was detected elsewhere within the lake. At this time of year, water temperatures were above 27 degrees or above 80 degrees Fahrenheit. It appeared as though this infestation was a fairly new introduction, and with the water temps being above spawning temperatures, no villagers or settlement had been detected. On October 1st of 2014, myself and a game warden visited with the marina operators and the staff regarding any vessels that may have been launched or brought to their marina in the past few months. The staff could only recall a couple of boats that had arrived, and they were all brand new boats, had not been launched on the water in any lake. However, after naming off the infested lakes in Texas, one of the staff indicated that a work barge had been brought in to do some repairs on their boat slips, and that the barge was still located within the marina. That work barge and its crew had come from Lake Belton, which is about an hour away from Waco, and was found to be infested with zebra mussels a year earlier. We located the work barge, and immediately I went to the back of the barge to the outboard motor and put my hand in the water and started filling along the lower unit and found several live zebra mussels. The game warden visited with the marina owner, and they contacted the barge's owner, and the barge owner was instructed to immediately remove the vessel from the water. Now, this is about 5 o'clock in the afternoon, and as I mentioned before, Lake Belton is about an hour away, so the game warden had to stay on site with the vessel until they arrived to remove the vessel from the water. After removing the barge from the water, further inspections revealed that it was highly infested. It's important to note that subsequent inspections of other vessels and boat slips in close proximity to where the infested barge had been kept revealed no zebra mussels. This included dive inspections as well as the removal of a vessel that had been in the water for over a year for a close-up onshore inspection by 3 TPW biologists. Given this information, the game warden issued 3 citations to the vessel's owners. The first one was for possession of an invasive species, the second was for transportation of an invasive species, and the third was for not having the vessel properly registered. Now, additional surveys, including those done by scuba divers, only again revealed zebra mussels near the private boat ramp. So on October 3rd, 2014, the City of Waco, the U.S. Army Corps of Engineers, and Texas Parks and Wildlife Department met to discuss the introduction and to discuss some possible treatment options. Chemical treatments were discussed as a possibility, but given that the lake is a drinking water source for the City of Waco, and that the amount of time would take to get the necessary permits, the use of chemical treatments were dismissed pretty quickly. As I mentioned earlier in the presentation, water temperatures were above 80 degrees at this point in time, but being in the fall of the year, we knew the water temperature would start cooling off pretty quickly, and we were afraid that we'd get into the spawning temperatures for zebra mussels. So given that information, it was decided to go ahead and try covering the area with heavy tarps to suffocate or to starve the zebra mussels that were located on and adjacent to the private boat ramp. Since we were working with the U.S. Army Corps of Engineers with these efforts, we were able to quickly obtain a National Permit 18 to do the work. In all, 9 tarps were ordered, and they were delivered on October 20th of 2014. The tarps were made of a 30 millimeter polyvinyl chloride. They measured 150 feet long by 35 feet wide and weighed roughly 950 to 1,000 pounds each. On October 21st, staff from the City of Waco, Texas Parks and Wildlife, and U.S. Army Corps of Engineers began placing the tarps over a football field-sized area, and the job was completed on October 23rd. Now, the tarps, to install the tarps, they were unrolled and pulled into position using a couple of boats. The tarps were overlapped by about 5 to 7 feet to help ensure a complete coverage and to make sure that water wasn't, tried to avoid any water that could be exchanged or get underneath the seams. The edges of the tarps were also left on the edge of the shoreline for several feet up the shoreline in case the water level happened to come up during the time that the tarps were in place. Commercial divers were hired to help install the tarps, and roughly 2,000 sandbags were used to secure the tarps in place. Now, the tarps were left in place for roughly 5 months. On March 17th through the 19th, we began removing the tarps from the lake. Heavy equipment was used to pull the tarps out of the water, and this actually worked out pretty well because as the heavy equipment was pulling the tarps up, it pulled all the sandbags with them up closer to the shoreline, and so the sandbags were actually pretty easy to remove. Now, anoxic conditions did appear to have been achieved over much of the area that the tarps were in place. While we were removing the tarps from the water, you could smell the hydrogen sulfide smell that you have when you have those anoxic conditions. And then also the bottom sides of the tarps were heavily covered with detritus or decomposing material and then black muck and any other evidence of decomposing organic matter. Following the removal of tarps, an intensive search by us as well as the scuba divers were looking at submerged rocks in the boat ramp area. Unfortunately, these searches did reveal a couple of specimens appeared to have survived the tarping project. Also, while conducting follow-up surveys on November 5th of this in 2015, and collecting plankton samples, a single live specimen was found near the boat ramp. However, since completion of the project, we have yet to detect any villagers or new settlement within the lake or anywhere near this boat ramp or on any of the boat docks or vessels in the area. So the $64 million question is, or maybe I should say the Powerball Lotto question is, did our quick response achieve a partial kill, or were we able to reduce their density enough to prevent a viable breeding population from developing? And that's a question that I think we're going to be waiting to hear to find out probably in the next year or two. That's the extent of my presentation. However, I do have a short video, YouTube video of the tarp installation, and I will go ahead and play that for everybody at this point in time. Here's the link for the YouTube video if anybody is interested.
Zebra mussels were found near a private boat ramp by City of Waco employees on September 26, 2014. The City of Waco, along with Inland Fisheries Division staff from Texas Parks and Wildlife Department, had been monitoring for zebra mussels on Lake Waco since their discovery on Lake Belton nearly 1 year earlier. Zebra mussels are an exotic species from Eurasia. And can rapidly reproduce in aquatic environments. Adult zebra mussels are currently known to exist in 6 other Texas reservoirs, and their discovery in Lake Waco is the most recent. Once established, zebra mussel populations can pose serious economic, environmental, and recreational problems, including the ability to infiltrate, reproduce, and eventually clog water intake lines and wreak havoc on boats and motors if left in infested waters. After the initial discovery, we extensively surveyed Lake Waco to determine the extent of the zebra mussel infestation. Zebra mussels were only found in an area 50 foot wide by 25 foot long around the private boat ramp. No adult zebra mussels have been found anywhere else on the lake. The plan to eradicate zebra mussels from this small area of Lake Waco was relatively straightforward. Use plastic to suffocate zebra mussels by depriving them of oxygen. The algae and debris under the plastic will break down through natural processes, removing any available oxygen. The plastic will be in place for a minimum of 4 months. We used a crane truck to lift and place each 1,000-pound roll of plastic near the shoreline. The plastic was then rolled out perpendicular to the water's edge and unfolded. Subsequent rolls were overlapped by approximately 5 to 10 feet, and the same procedure was used for each. 8 rolls were placed in total. Two boats were used to drag each length of plastic into the water. Once all plastic was in place, divers worked on removing air pockets out from under the plastic. Sandbags were delivered by boat to the divers and first placed along corners, edges, and seams to ensure the plastic was secure. Divers communicated with the crew leader via a sophisticated dive helmet, and the crew leader signaled how many sandbags needed to be dropped in a given area. This went on until the plastic was weighted down sufficiently. Lastly, we weighted down the shoreline plastic to prevent wind and/or wave action from moving it. Over 2,000 sandbags were used in all. Partners will collaborate to remove plastic and sandbags at an appropriate time after the 4-month period has passed. This type of effort has never been attempted on a scale this large before, and so the project is very unique in this respect. Let's keep our fingers crossed that these efforts pay off.
Okay. Erica, that was my presentation.
Great, thank you. We do have a couple of minutes that we can take a couple of questions for you now. So one question we have is, after the tarps were installed, did you have the divers monitor the DO levels underneath the tarps to ascertain the anoxic conditions were indeed achieved, or did you just go off visual observations or other observations to determine what the dissolved oxygen levels were?
Just off of visual observations. We did not have the divers. They were a hired staff from out of town area, and we did not have access to them for the entire time. So we just used visual observations.
Okay.
In hindsight, it probably would have been nice to have had potentially have some loggers placed underneath the tarps in various locations, but we didn't have that done either.
Thank you. The next question is, did you close the boat ramp during the treatment process?
Yes, we did. The boat ramp was closed for the entire time, and the entire area was marked off with buoys from the Army Corps of Engineers dedicated as a no-entry zone.
Thank you. We had one person ask if you were doing any additional control measures at this point. I'll just broaden that a little bit. If you could talk a little bit about what additional follow-up you're doing, if any, be it monitoring or inspections, or if you've planned any other additional control efforts.
At this moment, we don't have any additional control efforts planned for this particular location. We are continuing to monitor, though. We are going out and we're still doing visual surveys of the shorelines, of the boats and the docks in the area, as well as collecting plankton samples for microscopy and PCR analyses. But at this point in time, those monitoring efforts, we'll continue those on probably for the next coming years anyways, to see if anything develops or not.
Thank you. One person asked if you could share how much the project cost.
Okay, the cost of the tarps themselves and some of the sandbags and the other just miscellaneous material was around $30,000. That does not include staff time, that type of thing. But it was about $30,000 just to purchase the tarps.
Okay, we're just getting in a couple more questions here, and we do have a little bit of time, so I'm going to keep going through the list.
Yeah, no problem.
What is your plan for dealing with the remaining mussels? I think you said you saw one specimen afterwards.
Yeah. Again, like I said earlier, right now we don't have any additional treatment efforts. We're just going to continue monitoring to see if in fact a viable population does establish or not. At this point in time, we haven't had any indication that we've had any type of successful reproduction from the mussels that had fallen off of that barge.
And in case we missed it, somebody wanted to know if you said how thick the tarps were.
The tarps were 30 mil polyvinyl carbon tarps. So they're very heavy-duty tarps. They're tarps that are very similar to what's used for lining, like hatchery ponds or different types of ponds and things like that. So they're actually very strong tarps. We were able to walk on top of the tarps and stuff across the rocks, and it would not puncture through. So over the 5-month period, the tarps actually, well, they did eventually start wearing down. They all in all were held together very well and remained intact.
Thank you. Another person wanted to know if you identified any native mussels in the area and did you attempt to remove them prior to placement of the tarp?
We did not identify any, and the only searches we had done during our searches looking for the zebra mussels in the location, we did not document or find any native mussels in the area.
And we have a question regarding public reaction or did you get any reaction from the public who were may have attempted to access the site while it was closed, and did you do any outreach or public relations?
Certainly. Yeah, this boat ramp was located just within a private country club marina, and so the only people who had access to this boat ramp were in fact members of the country club itself. And so overall we had a fairly small impact to the recreation on the lake, and all in all, to be honest with you, the city of people of Waco and even members of the country club were very supportive of our efforts, and they appreciated what was being done. So, and we did do this. That YouTube video that we watched, that was something we actually developed in an effort to kind of educate the people about what was going on at the lake, at the marina, and just to give them all the public awareness about it. So.
Great. I'm going to take these last two questions, and then we'll move on to our next presentation.
Okay.
So the last two questions, one is why not extend the length of time the tarp were left out?
We had initially talked about leaving it in place for 3 months. We actually went closer to 5 months, and we decided at that point in time that eventually we'd have to get the tarps to be removed, and you start coming in closer to March and April and May. We started getting into the height of the boating season, and so we knew people were going to want to be utilizing that ramp, so we wanted to try to remove them before it got into the height of the boating season. And also, as I said, those tarps, as strong as they were starting to break down a little bit, particularly on the shoreline where the wave action was continually beating them up against the rocks, that type of thing. And so rather than continuing to have them to degrade further, we decided it was time to go ahead and remove them from the lake.
Thank you. So one last one, and then we'll probably continue to get questions in during the other presentations. So Brian, if you could hang on to the end, we might have a few more questions for you then. But the last question we'll ask right now is, were there any volunteers participating in the monitoring that was done, or is that just done by hired staff?
Most of the monitoring that's being done on Lake Waco is done by City of Waco staff or Parks and Wildlife staff. Great. We do have, along that lines though, given the boater surveys that are conducted and boater inspections at the public ramps on Lake Waco, those are done by hired summer intern physicians. So. Okay.
Thank you, Brian. As I said, we may continue to get questions for you, which we'll ask at the end.
Very good.
So our next presenters today are Ray Fernald and Brian Watson with the Virginia Department of Game and Inland Fisheries. Brian is an aquatic resources biologist and serves as the department's malacologist and has worked with the agency since 2002. Brian was the lead biologist on the zebra mussel eradication at Millbrook Quarry. Prior to working for the department, Brian worked for the North Carolina Wildlife Resources Commission and as a non-game aquatics biologist with a focus on freshwater mollusks. He obtained his Master of Science degree in Fisheries Science from Virginia Tech in 1998, conducting research on endangered freshwater mussels, and his Bachelor of Science in Marine Science Biology from the University of Tampa. Ray Fernald manages environmental programs for the Virginia Department of Game and Inland Fisheries with a primary emphasis on review of state and federal environmental assessments, permits, and projects that may impact the Commonwealth's fish and wildlife resources, and on coordination of department activities regarding invasive exotic species. Ray started with the department in 1990 as an environmental services biologist. Prior to that, he spent 13 years with the Florida Game and Freshwater Fish Commission. He has a bachelor's degree from Florida Southern College and a master's degree from Southern Illinois University. Ray also currently serves as chair of the Mid-Atlantic Panel on Aquatic Invasive Species. So with that, Ray, you should have control and can get started with your presentation.
Thank you, Erica. Just to confirm, do you have the right screenshot since I'm looking at two of them?
Yes, we are seeing your title slide.
Okay, great. Well, today I'd like to present a case study in eradication of zebra mussels from Virginia. In late August of 2002, zebra mussel infestation of an abandoned northern Virginia quarry was reported to our department. Millbrook Quarry was and remains a popular recreational and training scuba diving site serving the metropolitan Washington, D.C. area. The quarry, located in western Prince William County, was opened in 1947 to produce stone for construction of Virginia Highway 55, but has been inactive as a quarry since at least 1963. This slide depicts the quarry, the gated access road from Highway 55, and the adjacent streams, including Broad Run, Catlett's Branch, and an unnamed tributary. The dive shop in Fairfax, Virginia, first began using the quarry for scuba diving in the early 1970s, and has been leased by the dive shop as a training and recreational dive site since 1978. Diving occurs on weekends only and primarily from April through mid-November. There is no running water or electricity on site, and no public non-diving access or recreational use is permitted. The 4 floats in this picture support one of the half-dozen dive training platforms suspended approximately 10 meters below the surface. The quarry is separated from Broad Run, a perennial tributary of the Occoquan River, by a 60 to 90 meter wide berm from which this picture was taken. Well, following Broad Run about 9 kilometers downstream, you reach Lake Manassas, the primary water supply for the city of Manassas and surrounding areas. Further downstream lies the Occoquan Reservoir, a primary water supply for over 1 million Northern Virginia residents. And from there, the Occoquan River flows into the Potomac River and then downstream into Chesapeake Bay. On receipt of the report, our first action was to contact the dive shop and assign DGIF divers to confirm the infestation. Next, we informed the Commonwealth's Secretary of Natural Resources and confirmed our agency's authority to address the problem. And we then designated in-house leads for project management, technical field work and analysis, and dissemination of public information. And then we conducted scuba and snorkel surveys of Broad Run, Lake Manassas, and other popular dive sites throughout Virginia to confirm isolation of the infestation. And at this point, I'd like to highlight the timeline at the bottom of your screen that will track our progress toward eradication of the infestation. Well, on preliminary assessment of the threat to native wildlife communities, we established an interagency work group of state agencies, local governments, and other experts and stakeholders. Membership in the Millbrook Quarry Zebra Mussel Work Group was open to all interests, and we especially sought participation of local governments and of agencies with pertinent technical expertise or with responsibility for wildlife, environmental protection, public health, and potable water supplies. Given that no successful eradication of a large open water zebra mussel population had been documented, we recognized that we needed much more information regarding zebra mussels, the quarry, regional groundwater and surface waters, and the infestation itself before we could attempt to develop an eradication plan. During these preliminary discussions, we reviewed 7 potential zebra mussel control strategies, including pH shift, increasing salinity, dewatering the quarry, and treatment with chlorine, copper sulfate, potassium, or commercial molluscicides. We knew that to be successful, we would have to achieve 100% eradication, that we had to avoid adverse impacts to potable water supplies, and that other environmental impacts had to be minimized. So we focused on determining project constraints, additional information needs, agency assignments among the work group partners, and fieldwork protocols to ensure that we did not inadvertently spread the infestation to adjacent waters. We plan to conduct our field investigations at the quarry in mid-November 2002, but that effort was thwarted by access restrictions imposed by the property owner. Thus, we encountered our first roadblock. Fortunately, non-agency members of our work group recognized the dilemma and pursued introduction of the Virginia Non-Indigenous Aquatic Nuisance Species Act into the 2003 General Assembly. This law, that was signed by our governor on March 16, 2003, established the state non-indigenous aquatic nuisance species list and authorized DGIF to designate additional species as non-indigenous aquatic nuisance species via regulation. It gave us authority to conduct operations and measures to suppress, control, eradicate, prevent, or retard the spread of any NANs, and it provided that we may obtain warrants to inspect any property in Virginia to determine if NANs are present and to seize and eradicate any NANs found. Further, it stipulates that violations can result in a maximum fine of $25,000 per incident and liability for the costs of investigation, control, and eradication measures incurred by any state agency, local government, political subdivision, or authority. Coincidentally, or perhaps not, after passage of the bill by both houses of our General Assembly, and 2 days before the bill was signed by our governor, the quarry and dive shop owners granted us unrestricted access to the quarry. So we next moved on to data gathering and analysis. The lead agencies for the effort met in late March 2003 to review assignments, coordinate logistics, and approve the DGIF decontamination protocol. Our agency was responsible for mapping the quarry bathymetry and for assessing the distribution and density of zebra mussels. The Department of Mines, Minerals, and Energy was responsible for geochemical and hydrologic data collection and analysis, and the Occoquan Watershed Monitoring Laboratory of Virginia Tech was responsible for water sample collection and chemical analysis. And this field work was conducted during the 4th week of April in 2003. The first clip in this video presents a typical view of zebra mussel distribution on rocks comprising the side slopes and bottom of Millbrook Quarry from just below the surface to depths of about 21 meters. Sparse to dense clusters of zebra mussels were encountered throughout the quarry, both on exposed surfaces and in cracks or fissures within the quarry walls. Several diving attractions have been placed in the quarry, including an airplane, a cabin cruiser, and a bus, to name just a few. Sections of these objects were encrusted with zebra mussels from 1 to 3 layers deep, and the infestation was estimated to have originated 2 to 3 years prior to its being reported to DGIF. The densest populations observed occurred on the undersides of diving platforms suspended about 10 meters below the surface, as seen here, and were estimated at approximately 20 to 30,000 zebra mussels per square meter. Well, this rather dense slide depicts the formal process through which we derive the volume of the quarry. Essentially, through scuba, boat-mounted depth finder, and laser survey data points, we created a depth profile from nearly 800 positions in the quarry. And then, through GIS and ArcView, we created a three-dimensional model of the quarry, thereby estimated to have a volume of approximately 180 million gallons, or 680 million liters. While we addressed the quarry bathymetry and zebra mussels, the Department of Mines, Minerals, and Energy and the Occoquan Watershed Monitoring Lab focused on geologic, hydrologic, and chemical aspects of the quarry, the surrounding surface waters, and regional groundwaters. So in essence, DMME and OWML determined that the quarry has a very limited surface watershed, increasing its relative isolation from surrounding waters. And that groundwater flow proceeds through the quarry from north to south, and that leakage from the quarry to the regional groundwater occurs at a rate of about 3 to 4% of the quarry volume per year, and also that the water chemistry of Millbrook Quarry largely reflects the regional groundwater as opposed to the adjacent surface waters. And here you see the surface waters in the area surrounded with the golden circles, whereas the groundwater and Millbrook Quarry water chemistry are sequestered together in distinct groupings. Well, completing those analyses took a couple of months, and the three agencies then met in July to review the data and their implications for our efforts. At this point, we initiated an emergency procurement through issuance of a formal request for proposals. We had rather naively presumed that once we actively sought proposals for eradication, offers to fund the project would be forthcoming from work group agencies, local governments and industry, and other sources. Unfortunately, these offers did not materialize, so after reviewing the proposals that had been submitted, we were forced to cancel the emergency procurement due to lack of funding. Adding insult to injury, we also were directed to postpone any further review of alternatives or project feasibility until funding was secured. Well, based on the proposals submitted for the failed emergency procurement, eradication was expected to cost between $150,000 and $800,000. A wide variety of funding sources were solicited, including federal agencies, state, regional, and local governments, and prominent industries likely to be adversely impacted by presence of zebra mussels in Virginia's waters. And over the next 11 months, we gradually reached our funding goal of $800,000 in pledges, and we were then authorized to proceed with the project. Well, having endured one failed emergency procurement and being 2 years into the project, we determined this was not a viable option, so we next considered competitive sealed bidding. But such awards are based solely on the lowest price, and since we could not pre-select the treatment option, neither could we define the project for bidding purposes. Thus, this option also was rejected, and then we turned to competitive negotiation. In this process in Virginia, the RFP provides flexibility in describing the purchase requirements, the criteria that we would use to evaluate proposals, and qualifications required of potential vendors. There is opportunity through negotiation to change all aspects of the project, including scope of work and price, and the process facilitates use of an evaluation panel. Well, anticipating the wide range of technical, public health, environmental, and socioeconomic issues to be considered, we assembled an interagency evaluation panel representing 7 agencies. These included the Department of Game and Inland Fisheries, the Department of Mines, Minerals, and Energy, and the Occoquan Watershed Monitoring Lab, the Department of Environmental Quality, and the Department of Health, and the Cooperative Fish and Wildlife Resources Research Unit of Virginia Tech. We also included Fairfax County Water Authority, now known as Fairfax Water. This inclusion of primary stakeholders and regulatory agencies on the RFP evaluation panel was intentioned to promote interagency support during subsequent environmental and permitting reviews. The other major steps in this process were to develop and issue the request for proposals, evaluate the proposals received, negotiate with selected vendors, and eventually we issued a $365,000 contract for the eradication to Aquatic Sciences LP of Orchard Park, New York. After awarding the contract, we had to address federal and state environmental review and permitting requirements. Because funding was provided through federal grants, we had to prepare an environmental assessment in compliance with the National Environmental Policy Act. Our proposal also was subject to Virginia's Environmental Impact Review, coordinated through the Department of Environmental Quality. And we had to ensure that our grant agreements and the project complied with federal and state endangered species laws and regulations. We had to receive a determination of consistency with the Virginia Coastal Zone Resources Management Program and the Coastal Zone Management Act. And finally, because our selected treatment, infusing the water column with potassium chloride, was not a registered pesticide use, we had to apply for a special quarantine exemption under the Federal Insecticide, Fungicide, and Rodenticide Act. And that required approval by the Virginia Department of Agriculture and Consumer Services and by the federal EPA. Embedded in these procedures were notification of every potentially affected landowner and significant public review requirements. And essentially, we sent individual letters to every landowner from the quarry downstream to Lake Manassas. Well, finally, our proposal was approved by Virginia's Secretary of Administration on December 1st, 2005, by the U.S. Fish and Wildlife Service on December 2nd, 2005, and by the Environmental Protection Agency on January 20th, 2006. Within 2 weeks of our notice, the contractor mobilized on site. We reviewed and confirmed the operational protocol and schedule, emergency procedures, and project oversight, and treatment began on January 31st, 2006, 3 years and 5 months after initial confirmation of the infestation. To kill the zebra mussels through exposure to potassium, The entire quarry was injected with over 650,000 liters of a 12% potassium solution, and this was equivalent to 131,000 kilograms of muriate of potash salt. The solution was delivered each Monday through Friday to the site by a tanker truck, and it was then pumped from the land-based storage tanks through a floating supply line to a 21-foot workboat outfitted with a specially designed diffuser manifold on its bow. This slide presents three-dimensional animations of the potassium concentrations measured at various depths along fixed transects after each 5 days of treatment. To our surprise, 24 hours after the first week of treatment via surface spray and use of hoses up to 10 feet in length, the potassium was evenly distributed throughout the water column at approximately 1/3 of our intended target concentration. We had been concerned that density differences between the water and potassium solution and seasonal thermoclines might prevent or retard potassium diffusion throughout the water column. But after the second week of treatment with 3-meter discharge hoses, the same hoses in fact, the potassium was evenly distributed at about 60 to 70 parts per million. And after the third week of treatment, every monitored point in the quarry revealed a potassium concentration of approximately 100 parts per million, and 100 parts per million was our target concentration of potassium. Thus, after 3.5 years of planning, the actual eradication, staging, treatment, and demobilization were completed in less than 1 month. Our plan and contract, however, required multiple confirmations of success. First, 6 weeks post-treatment, we examined over 1,000 zebra mussels collected from rocks and shallow waters around the quarry periphery and found no living zebra mussels. Second, our agency divers who had conducted the initial survey of the infestation conducted another scuba inspection of the quarry and found no living zebra mussels. And third, our contractor conducted extensive video survey and documentation of the dead zebra mussels through use of a robotic camera. During 2 days of robotic surveys, the quarry walls, dive attractions, and training platforms were inspected, searching for evidence of living zebra mussels. No living zebra mussels or Asian clams were observed, nor did we see any evidence of fatality of any species other than zebra mussels and Asian clams. The second video clip reveals live and apparently unaffected largemouth bass and bluegill in a shallow area of the quarry. And this final clip reveals dead zebra mussels on the underside of one of the dive training platforms suspended 10 meters below the surface. Decaying flesh of zebra mussels can be seen falling from the shells, especially when disturbed by the water jet exhaust of the robotic vehicle. Similarly, on death of the zebra mussels, the byssal threads also decay, and large numbers of dead shells can be observed being flushed off of the dive platforms by the exhaust jets of the departing submersible. And finally, bioassays of live zebra mussels imported to the quarry for this purpose and placed at various locations and depths throughout the quarry suffered 100% mortality within 31 days of exposure to the treated quarry water. None of the control zebra mussels exposed to water drawn from Broad Run during the bioassay period died. After confirming the eradication, we continued post-project monitoring of the quarry's water chemistry and microbenthos of the quarry sediments, and we also monitored potassium levels in adjacent surface waters and both potassium and chloride levels in local wells through January 2008. Though potassium levels had declined to about 70 to 75 parts per million by 2008, no adverse or unanticipated increases of potassium or chloride were detected in adjacent surface or groundwaters. So, to summarize, in many respects, our success at Millbrook Quarry reflected the nature of the infestation and setting. And that is, the quarry is essentially isolated from other surface waters. Groundwater connections were insufficient to dilute the potassium below the desired concentration or to result in downstream contamination. There was no uncontrolled public use or access to the site. All field work, including treatment and bioassays, could occur on weekdays or during winter when no diving was scheduled, and there were no sensitive or imperiled native species that precluded our use of potassium for the eradication. Other major factors in the success included our firm decision to pursue eradication if possible, despite significant risk of failure, the eradication of an effective interagency work group to leverage expertise and political support, passage of effective enabling legislation, review of proposals to an interagency RFP evaluation panel, project design and contract development via competitive negotiation, and maintenance of interagency and public support throughout the course of the project. But even so, we encountered substantial hurdles, including the lack of pre-existing clearly defined agency authority and mandates and responsibility to address invasive species issues, the lack of pre-prepared invasive species management strategies and rapid response plans, the complex and resource-intensive procurement and environmental documentation and compliance requirements, and the lack of invasive species program dedicated funding and staff. And in the end, though, our success was due to efforts of the work group, the RFP panel, cooperating agencies, and an outstanding contractor, and to virtually unanimous public support. Despite the project's lengthy gestation, we think it represents a good example of interagency and public cooperation in addressing an invasive species infestation. And that's the end of the presentation. The only thing I would like to add is that to note that in 2013 and 2014, we did an additional 24-month follow-up of the water quality in the quarry and surrounding wells and surface waters, and we found that the potassium concentration had declined down to about 36 parts per million over the last 8 years. Other than that, there had been no significant water changes. And that's it, Erica.
Thank you, Ray. We have time for just one or two questions right now before we move on, and then we'll hold the rest of the questions till the end. So the first question for you is, how were the monitoring locations being monitored throughout the application period? Was that through equipment on a boat or data loggers in the quarry or something else?
As we distributed the chemical, it would be distributed over a 5-day period, and then over the ensuing weekend, they would go back out with both electronic monitors from a boat and also grab water samples for a lab analysis later.
Thank you. And then one person asked, where did the infestation come from?
We were never able to improve it, but considering there's no public use of the quarry except for diving, and it's a very popular dive site, we're fairly confident in saying that the introduction was probably on dive gear or introduced by divers, either intentionally or accidentally.
And then the last question before we move on, and like I said, we will probably get several others, so we'll hold those to the end. But the last question for now is, were recreational activities suspended during the treatment period?
As I said, normally the diving only occurs from April through November, and so we conducted the actual eradication from the December 31st into January. So there was no scheduled diving during that period. Typically, they will have one or two what they call chilly willy dives or things like that, and they were just scheduled, canceled during the treatment. The only time that we had to really modify the proposed diving schedule was during the bioassay period, when we just closed any access to the quarry. And but there was really no significant diving scheduled during the time we were working in the quarry anyway.
And to be clear, diving is the only recreational activity that occurs at the quarry?
Yes, it's leased entirely by the dive shop, and the only other recreational activity that's allowed is that the divers themselves and their immediate families are allowed to camp there on Saturday night. It's a tent-only type camping situation with no running water, no utilities. Other than that, there's no boating and no other recreational use, and no public access to the quarry.
All right,
but it is very heavily used by divers, however, on weekends.
Right. All right, thank you. We're going to move on to our next presenter and hold the rest of questions for you till the end.
Thank you.
So our final presenter today are Keegan Lund and Kylie Kessler from the Minnesota Department of Natural Resources. Keegan Lund is an aquatic biologist with over 10 years experience working with both terrestrial and aquatic invasive species. He serves as the Metro Area Invasive Species Specialist with the Minnesota DNR, and his work focuses on prevention, monitoring, and management of aquatic invasive plants and invertebrates. Kylie is a Natural Resource Specialist with the MDNR. She works with Aquatic Invasive Species Program on prevention and management efforts associated with aquatic invasive species. She was integral in the field monitoring of the Christmas Lake project, which we're going to hear more about today. We've invited Keegan and Kylie back to talk a little bit about some of the other efforts that have been going on at Christmas Lake. So, Keegan, you should be all set.
Thanks, Erica. Alrighty. Can everyone see our screen okay?
Yes.
Okay, we'll get started. So, Keegan and I were first invited here for a webinar back in July where we talked primarily about the Zequinox treatments that were done in Christmas Lake. So, this presentation will just sort of be a continuation of that story. So what we hope to cover is I'm going to briefly go over sort of some background history on Christmas Lake, talking about the initial infestation that took place in 2014 and some of the response efforts that occurred after that. And then Keegan's going to go into more detail talking about two specific pesticides that were used to control for zebra mussels in this lake. One was EarthTech QZ, it's a copper formulated product, and then potash, which we've already heard a little bit about. Finally, going into some of the post-treatment monitoring, and then touching upon some of the lessons that we learned and some takeaways from this entire project. So to start off with some background information, here you have our study site, which is Christmas Lake. It's highlighted in this box in yellow, located about 20 miles west of the Twin Cities area. It's a fairly small lake, about 250 acres, and also fairly deep, so about 87 feet as its maximum depth. Extremely clear. It's in close proximity to Lake Minnetonka, which is one of the largest, most probably heavily used recreational lakes in the Twin Cities area. And this Lake Minnetonka has had zebra mussels in it since 2010, so in close proximity to our study site. Christmas Lake is located in the Minnehaha Creek watershed, and the watershed district in particular was integral partner in this project. To provide some background, they have a fairly robust early detection monitoring program that's been in place since 2010. And currently they have 2 full-time AIS staff members that do AIS baseline assessments to many of their lakes in the district on an annual basis. So they were the ones that first discovered the infestation in Christmas Lake, which occurred in August 16th, 2014. They found 1 zebra mussel on a settlement plate, which was suspended near the public boat launch. We knew this was a new infestation because they checked this plate about every 2 weeks. So 2 weeks prior, they did not find any zebra mussels, and then on August 16th, they found one. The DNR went out and confirmed that they were in fact zebra mussels and did additional lake-wide surveys on that day. In total, we found about 5,500 juvenile mussels surrounding the public boat launch. So from there, a series of stakeholder meetings took place, and this was to discuss, what are our goals with the situation that we have, what possible control methods can we use, and it was determined that the best course of action was to temporarily close the public boat launch and also to install a containment barrier to quarantine the infestation. And so during that time, the DNR, in addition to the watershed district, were able to do a number of additional population assessments, which I'll go into some more detail in a few slides, and to determine what the extent of that population was. And then the first control effort took place on September 8th, which was about 3 weeks after the initial infestation. So with those stakeholder meetings, some project partners that were involved included the Minnehaha Creek Watershed District. The University of Minnesota has a aquatic invasive species research center, so a faculty member from there that have knowledge of zebra mussels assisted in a lot of the development of such protocols. Blue Water Science Consulting, PLM, who's our applicator, Christmas Lake Association, and finally the City of Shorewood. So upon the initial infestation, we wanted to figure out how big was the population, or whether it had spread lake-wide. So asking questions such as, is the population lake-wide, and is the population reproducing? So we conducted approximately 100 plus hours of survey work using snorkel and scuba methods. We did transect surveys, plankton tows to search for veligers, and after doing all this monitoring, we determined that this was a new infestation. The only mussels that were found were near the public boat launch. So I apologize, the map is small, but that red diamond in the northwestern corner, that's where the infestation was. That's where that one public boat launch is. So that's where the mussels were isolated towards. And then of the mussels that we did find, there were no adults or additional veligers found, just those juveniles. So we wanted to develop some sort of pre and post-treatment monitoring protocol where whatever pesticide we were going to select, we would be able to monitor both the concentration of that pesticide as well as determine whether it was selective. So evaluate and look at zebra mussel mortality. And we did this by collecting water samples during treatment and after treatment and submitting them to the Minnesota Department of Agriculture. In addition, the DNR purchased field equipment to measure residual concentrations on site. And then in terms of zebra mussel mortality, we tested this through laboratory tank trials. So selecting a small number of zebra mussels, placing them in these tubes, and placing the product in the tanks and monitoring the mortality across multiple days. So to provide kind of an overview of this project, our ultimate objective was to eradicate zebra mussels, or attempt to eradicate zebra mussels from Christmas Lake in this small area. And there were 3 pesticides in particular that we were interested in using. The first one was Zequinox, which we won't be going into a lot of detail today, but I'll provide a little bit of background information. And then Keegan will be talking about EarthTech QZ, which is a copper product, and Muriate of potash, which is potassium chloride. We wanted to follow this pre and post-treatment monitoring protocol, so we'll provide some results from that. And then also it was essential that we use some sort of enclosed treatment barrier to maintain product efficacy. So we'll revisit this map again, but this kind of gives you a snapshot of all of the different treatments that we did in Christmas Lake in 2014 as well as in 2015. So we'll go into more detail about these, but this just gives you an idea of the different areas, which are outlined in the different colors. The dates indicate when those treatments occurred, and then in that table up at the upper left corner, you have the different products and how big of acreage for each treatment. So not going to go into a whole lot of detail, but the first product that we used was Zequinox. It's manufactured Marone Bio Innovations. It's a biopesticide, so this consists of dead bacteria cells, Pseudomonas fluorescens, which are actually ingested by the zebra mussel as they filter them through, and it eventually destroys their digestive lining. And the interesting part about this biopesticide is the mussels can't necessarily detect or sense this product in the water column in comparison to other products like copper and chloride. So it's an interesting one to use. It has relatively low toxicity and presents very little risk to other organisms, which includes native mussels. And it's only been really used in very few in-lake experiments using Zequinox. So Christmas Lake was one of the first ones to actually test this in a real-life application.
Okay, this is Keegan. I'm going to continue on with some information regarding EarthTech and potassium chloride. So as Kylie mentioned, EarthTech is a copper-based pesticide. It is copper sulfate pentahydrate, and the cupric ion form, I guess, would be the active ingredient. It can be somewhat selective depending on concentrations, but copper-based pesticides are used for a variety of applications, and at the right concentrations can have can be used to control other organisms. Potential non-target effects of these treatments would potentially be invertebrates, fish. The label was first approved by the EPA in May 2014. So a brief overview of what happened with EarthTech. The previous label at the time of the treatment had a restriction on how frequently one could use the product. We needed to work with the Department of Agriculture, the Minnesota Department of Agriculture, to request special local needs in order to use the label in a way, I guess, differently than as it's stated. The treatment area was roughly 3/4 of an acre. Product cost and labor was around $1,500. Barrier cost that we expanded was $2,700. And it was a treatment window between October and November of 2014. The target concentration for EarthTech QZ is 1 part per million. So both of the products that we used presented some obstacles in terms of either registration or their current label status. EarthTech, we needed to receive a 24C special local needs. Again, that request was sent to the Minnesota Department of Agriculture so that we could use the product at greater treatment frequency intervals. So the label said you could not treat any more than 14 days. We needed to treat much more actively in terms of maintaining copper levels over time. The approval process took roughly 5 weeks, which was very quickly, we felt, and MDA was integral in helping to move that SLN registration through. One note, the federal label actually changed this summer, July of 2014, to include these new treatment frequencies. So now the product may be used, I guess, more robustly for potential in-lake or partial lake zebra mussel treatments. So some of the data that we found based on our aquaria trials, the product was very effective, and this is supported in the literature. We took treated water and put them into our aquaria trials. The reason why we weren't able to monitor in-lake mortality was that our initial treatment of Zequinox basically removed our samples. And so what was left was very few zebra mussel individuals that were found on subsequent surveys. So we didn't have enough zebra mussels to test in the lake. There was really not interest by our partners or the agency to introduce mussels in order to assess mortality. So that was the reason for these aquaria trials, trying to replicate as best possible. Mortality was achieved between 7 to 9 days with both products, EarthTech QZ and potassium chloride. The next product that we used was potassium chloride, or muriate of potash. Potassium here is the active or lethal ingredient that interferes with gill respiration in terms of zebra mussels. It is a very selective product. That what should be said here is it's highly selective to zebra and quagga, but it also will harm native unionids, native mussels. This product as well was not registered for use, but had been used in a variety of applications, as some of our other presenters have discussed. To use this product in Minnesota required an emergency exemption to the EPA. It was roughly a 9-week process in order to get this registration from preparation to approval. The emergency exemption was written for 2 lakes. We actually had another lake which we were working with a response plan at the same time, Lake Independence nearby. And we eventually did 3 treatments with potassium chloride. The first in December 2014 was an application under the ice, as the photo on the upper right shows. And then again, we treated in June and July of 2015. And I'll walk through kind of how each of those treatments unfolded when I come back to the treatment map. So efficacy, again, pretty similar. And this, again, is tank trials or aquaria trials. It should also be mentioned that we did monitor product concentrations in lakes in both trials. We worked with the Department of Ag and their lab to run copper levels and also potassium levels, and then we also photometer to to get more current information in terms of ingredient or concentrations in the water at time. 100% mortality was achieved with potash by day 9. Bump treatments again were necessary with both treatments to maintain concentrations at lethal levels. These were small contained areas separated from the rest of the lake with a impermeable barrier. But again, as tight as we tried to place these barriers, there was dissipation and potential loss to the other parts of the lake. So spring of 2015, just wanted to go through a bit of our survey efforts and why those response treatments took place. In April of 2015, again, this is after our winter treatment, our scuba divers surveyed inside the treatment area and outside, and no mussels were found. And then the watershed district, again, a very active partner in this process, helped organize an entire lake perimeter survey through snorkeling, scuba, and wading. I think we had roughly 18 volunteers work the entire shoreline of the lake. 10 mussels were found outside of the winter treatment area by scuba divers. So what happened then was June, that area was enclosed and treated with potassium chloride, and then a request came to the Department of Natural Resources for an expanded treatment, including that and all other previously treated areas, and that was approved. And in July of 2015, the large 10-acre area was treated with potassium chloride. This just shows a bit of our survey efforts. The purple dots going around the lake are individual survey sites. Actually, we surveyed the entire shoreline, so dove between each of those sites, but it was divided out that way so that survey groups could tackle, I think, roughly 5 parcels between the groups. It shows where the zebra mussels were found in May, and let me move on one. So now this map hopefully makes a bit more sense. It shows all of our efforts. It should be said that really this was you know, an experiment or an experience in adaptive management. The black box on the left shows the initial area of infestation and the equinox treatment, followed by what was done in October in blue using Earth Tech and potassium chloride later under the ice. And then the polygon in green shows what was done in June after spring surveys. And then finally the red polygon showing roughly 10-acre area of potassium chloride. So after the last treatment that was done, I'll just go a few more minutes. After the last potassium chloride treatment was completed in July, there was extensive post-treatment monitoring through summer and fall using snorka, scuba, and also plankton tows were conducted. There were no zebra mussels found through these monitoring efforts from last summer. Unfortunately, on October 19th, a lake service provider, so a contractor who installs docks, found a zebra mussel attached to a boat lift on the south side of the lake. This is not within any previous treatment areas. A few days later, we went out and did some scuba assessments, or I'm sorry, snorkel assessments in very cold water, and found approximately 10 zebra mussels scattered throughout the lake, not within any of our treatment areas, but outside of these treatment areas, suggesting successful reproduction and settlement. You know, likely there was a reproductive group of zebra mussels that was obviously outside of our treatment areas. So this map briefly shows what happened in October of 2015. Green dots scattered throughout the lake are shoreline inspections. Red dots are zebra mussels. Again, obviously spatially dispersed throughout the lake. And we also found a variety of sizes of zebra mussels, you know, from potentially reproductive size to juvenile size throughout the lake. So briefly, some lessons learned, and I think we went through these on the Sequinox presentation in the past, the importance of early detection monitoring. Without having eyes on the water, people in the water on a regular basis, it really is difficult to respond quickly to new infestations. The importance of population assessments. We snorkel, we dove, we did it again, and still we would find more mussels. And so finding zebra mussels in lakes, especially lakes with extensive aquatic vegetation, really is a difficult endeavor. Another takeaway, treatment area size. How large do you treat? As our treatments unfolded and we learned more and more, in hindsight, it would have been good to expand the treatment area to as large as possible and reasonable initially, but it should also be said that many of these products did not have labels that would have permitted that, and our experience, as we went through this experience, we learned as we went. Also, the importance of monitoring concentrations in the water of your pesticide was really integral. Working with labs in terms of getting concentration numbers, although very accurate, there was some lag time, and we needed to have actual target concentrations in the water as we treated. So that was very important. And then also, or lastly, working with the many stakeholders that we did, maintaining communications, meeting regularly, and also how we messaged this process to the media was really integral in terms of keeping everyone on the same page and in agreement in terms of our process. So that is all we have.
Thank you, Keegan and Kylie. So as a reminder, if folks have questions, to please type them in, and we will read those off for our presenters. Keegan and Kylie, I don't see any for you yet. So I'm going to go back to Ray and Brian in Virginia. If you're still there, we had a couple more questions come in for you.
I'm here. Brian, are you here?
Yeah, I'm here.
All right.
All right, so back to Millbrook Quarry. One question we have was, were Asian clams identified at the same time as zebra mussels, or were they found during the following investigations? And were the levels in the quarry as dense as that of the zebra mussels?
Take that one, right?
Yeah, go ahead. That's fine. Sure.
Asian clams were in the quarry. We didn't identify a specific density in comparison to the zebra mussels. In subsequent assessment of the quarry after treatment, we did see numerous dead Asian clam shells scattered around the shallow areas within the quarry, so we assume most or all the Asian clams that were in the quarry were killed as well, since the potassium targets bivalves, and there is a population of Asian clams in the adjacent broad run. So it wasn't unusual that we would see them in the quarry as well.
Thank you. All right, this is a sort of a two-part question for Keegan and Kylie in Minnesota. And regarding your takeaways from Christmas Lake, would your takeaway using these chemicals be a viable and cost-effective option for a 200-acre lake then, or not at this time? And related to that, would you undertake these efforts again?
Sure. In terms of cost-effective, that obviously depends on your management goals and the groups involved. I think in terms of partial lake treatments, could our efforts be replicated? Most definitely. It is a viable, I think, response or effort, and in the right situation with the right data in terms of population assessments and in-lake monitoring, I think potentially or hopefully other results could be achieved in terms of possible eradication in other lakes.
And this also is for Keegan and Kylie. What was the average calcium levels in the lake?
calcium was never monitored in terms of if those levels would be supportive of zebra mussels. They obviously are in terms of them being able to sustain themselves over time. We'll have to see in terms of what the population looks like. It is potentially bound by calcium levels. I do not feel that, so densities might not be what we see in other Minnesota lakes, but I think zebra mussels will not have trouble in Christmas Lake.
All right, and still with Christmas Lake, do you have an active boat inspection program? And if you do, how do you think the lake was infested?
Sure, that's a good question. Christmas Lake is actually a really unique lake in that they have a 100%, I guess, inspection policy. The Lake Association and local units of government have full-time inspectors that are at the lake. The lake has a gated access. There is only one access. And so as boat recreators come in, their boats are inspected, they can launch. If the gate is closed, no folks, can use the lake. In terms of how the introduction could have taken place, I couldn't say.
Okay, thank you. Another question for you at Christmas Lake. What was the total estimated cost, if you can share that?
Sure. So product cost, material cost, and also hiring consultants and divers. Total cost around $65,000. That doesn't include labor of the watershed district, the DNR, or some of our other local units of government.
And again, on Christmas Lake, was this a project to evaluate the efficacy of the 3 different products? And given your experience, is there a single product you would use for future treatment?
Our focus was not to evaluate these products because there was limited information on these products and also limited experience in Minnesota. We felt the need to evaluate them as best we could. In terms of which product is better, I think we still need more information in terms of the assessments of all these products. Each product has kind of pros and cons in terms, that vary between cost, non-target effects, etc. But there really does need to be, I think, ongoing research on these products to say more fully in terms of their efficacy.
Thank you. I have one more question for Keegan, you and Kylie, and then I'm going to go back to our other panelists again. Did you find any non-target mortality with the use of the Earth Tech?
I don't believe any was observed. I don't know if I mentioned this, but there are native unionids, native mussels in these waters. No non-target effects were not observed with Earth Tech with potassium chloride. We tried to move the majority of the native mussels. We cleaned and then relocated them outside of the potassium chloride treatment areas. There was observed mortality with native snails and a few native mussels that were missed, and so there was some mortality associated there. There was no fish mortality observed in any of the treatments.
Thank you. All right, I'm going to go back again to Ray and Brian in Virginia. What were the dissolved oxygen levels in the quarry after the potassium chloride treatment and the death of all of the zebra mussels?
Brian, do you have a quick answer?
I do not. I was actually pulling up some of the Excel files that we had from the water quality monitoring that was done in anticipation of some questions. Right. And I just got one up from March. This was through March 1st of 2006. So this would have been, about a week or so after final injection of the potassium chloride, and just doing a quick scan of DOs. I'm seeing in the 11 range. Now that would not have probably been in the window when we were seeing a large amount of the mortality, since temperatures were fairly low still at that time, but they still seem to be fairly elevated as far as into early March. Just trying to see if I had another one I could open real quick here. Yeah, this one gets into April, mid-April, late April, and I'm seeing similar numbers, 11, 10 through 14 milligrams per liter. So it doesn't seem to have affected the DO at all within the quarry.
Right, and one thing I sort of alluded to, but didn't really mention, while we were actually doing the eradication and the treatment, we had two different groups doing the water chemistry and water quality monitoring. The contractor was doing it, and the Aquaquarter Watershed Monitoring Lab of Virginia Tech was basically doing parallel water chemistry and water quality analysis. So we had two checks on those parameters.
Thank you. So along those same lines, Ray and Brian, based on ambient water quality parameters, how did you choose the target effective environmental potassium chloride concentration for your treatment?
Brian, you want to do this?
Sure. Yeah, well, I guess talking with the contractor and looking at some data that they had run from bioassays with zebra mussels, we were looking at an effective concentration probably in the 20 to 30 part per million range, depending on temperature within your water, to get 100% kill over about a 30-day range. We wanted to be, I guess, as conservative as possible, so we were shooting for about 3 times that concentration to get effective kill throughout the entire quarry, because there was some concern about complete mixing, whether we would get target concentrations at depth particularly. So we thought going with about a 3 times concentration level would ensure that we would at least hit a 20 to 30 part per million target throughout the quarry. And that would also provide a faster mortality time with the higher concentration.
Thank you. And we have a couple more for Ray and Brian. Do you know the estimated number of people that worked on your effort?
You mean including all of the other agencies, et cetera? When we went out there to do the field work, we probably had 30 to 40 people from DGIF. That was including a number of biologists, divers, law enforcement, engineering and survey staff, people responsible for helping us write grants, etc. We also had probably 3 or 4 people from each of the other major agencies. So I'd say, Brian, probably 30 to 50 people working on the project at some point or another, having a significant role.
Yeah.
In terms of the actual people who actually stayed with it from start to finish, I'd say there were 8 of us on the evaluation panel and a crew of 4 to 6, depending on what activity was going on with the treatment and monitoring. So we had probably maybe a dozen people kind of involved in the project from start to finish. Is that fair, Brian?
Yeah, I would agree with that, Ray.
And then, thank you, one more question for you two. Was there any attempt to determine where the divers were coming from to the quarry?
Well, where the divers are coming from, this is a very popular training site. So this one dive shop, it's a popular dive shop in the city of Fairfax, actually leases the quarry, but they sell tickets for divers, and they'll have 100, 200 divers there on any given weekend during the spring, summer, and fall, on Saturday and Sunday. And it's a low, You can go to look up Lake Millbrook or Millbrook Quarry, and dive shops throughout the area will do training and recreational dives in the quarry. So we know that divers come down to the quarry from all the mid-Atlantic states, for example.
So you do have people coming from out of state, you think?
Oh, absolutely. And they'll come down and dive at Millbrook Quarry one day, and then go down to Lake Rawlings the next day, and then go on down to North Carolina and dive off the coast. So it's traditionally for many years been a very popular dive site.
Thank you. So we have a few more questions for Brian Van Zee in Texas. Are you still there, Brian?
I am.
All right. Somebody asked what was the total area that was tarped, and how far did the tarps extend adjacent to the ramp?
Okay. I think we were estimating roughly around 4,200 square feet, roughly was the area that was covered by the tarps. And when we did our first assessments, we went off to, we know which side of the boat ramp this particular vessel was launched. In our conversations with the marina owners and operators and the operator or owner of this barge, in fact, we know that the barge was actually launched in July of 2014 on the lake, and they recalled knowing that which direction this boat was launched on, which lane of it, and that. So we focused on this lane. Most of it, we covered the entire boat ramp, though. We went off to the left-hand side of it, if you would, for probably about 30 to 40 feet, and then the rest of it was on the right-hand side, taking that path that the barge would have taken, then traveling back into the actual marina where they were doing the work.
Thank you. And I know you talked a little bit about the private property owners there, but could you talk a little bit more if they had any reactions to closure of the ramp while this was ongoing?
At first there was they were obviously concerned. Their biggest concern was that not so much about the lack of access to the members from the country club members, but more or less they were concerned about having fingers pointed to them as being liable for the actions of this vessel owner's actions predominantly by the city. And but because they were concerned with it, they were very willing to work with us. And so they like I said, they were very good. We had signs up at this ramp just warning boaters about aquatic invasive species and need to clean, drain, dry, and that kind of thing. And yet this vessel owner still went ahead and launched the boat. And it's kind of ironic, really. This vessel owner, he came from Lake Belton, which I had mentioned in my presentation, and became infested, or was documented to be infested in 2013, almost a year prior. And in our conversations with him, while we were doing our initial assessments and surveys of the area, trying to identify just how far they were distributed or where they might be located within the lake, we had actually talked to this crew of individuals and the marina, talked to them. They said they were familiar with zebra mussels. They hadn't seen anything. They allowed us to look on the boat slips and the flotation devices that they were taken out from underneath the slips and everything. We did not find any zebra mussels whatsoever. And lo and behold, here was their vessel they brought in, and they admitted that they did not clean. So,
thank you. And similar, just a couple more questions for you, Brian. Folks wanted to know if you're considering or are going to now require that ramp or other private ramps to be inspected?
No, not right now. We are still utilizing, the City of Waco is still hiring their summer interns. We have a boater inspection program at the public boat ramps and that type of thing. This ramp, this marina is privately owned. There's another one on the lake. And what they do is they're working with the Corps of Engineers, and they're talking to them, and they've been instructed on how to talk to the boat owners, where to look, find out where they're coming from and stuff. But we don't have a thing in place that monitors necessarily whether or not they are actually doing that whenever a vessel shows up.
Thank you. And we had a follow-up on the question related to citizen volunteers being involved in monitoring. Are you considering incorporating citizen volunteers in the future, utilizing the owners of those marinas to help with monitoring in the future?
Well, yeah, like I said, we have been in touch with the owners of the marinas and stuff, and you know, again, they have indicated that they're willing to try and do what they can. Now, whether or not they're actually doing it every day, if they're checking every single boat that comes in, I can't answer that. You know, the volunteers, certainly we would utilize them, but as of right now, the city of Waco still is hiring, in terms of a actual, what do I say, sanction, kind of a boater inspection type of program. The city of Waco is hiring those summer interns to do that. So.
All right. We do have at least 3 more questions, and these 3 questions I wanted to pose to all of the panelists. So you can all share your experiences or lessons learned on these questions. The first question that I want to pose to everyone is, have you ever thought of using sodium chloride instead of potassium chloride?
This is Keegan. I'll take a first inadequate stab at that. You know, our choice in using potassium chloride was based off the experience of other projects, including that at Millbrook. I couldn't speak to any lethality of sodium versus potassium.
This is Brian in Virginia. We did consider raising salinity levels in the quarry. There was, I think there was a couple companies in the area that had a byproduct, a liquid saline solution that we can the amount and the potential that we had to raise the quarry to for salinity levels to actually potentially kill zebra mussels. In comparison, we thought it was cost prohibitive for us, and we weren't sure exactly what concentration levels we were going to have to get up to without doing some bioassay work. So we ruled that one out in comparison to potassium chloride, since we knew the potassium was fairly lethal to bivalves at much lower levels, and the salinity would also kill pretty much every other freshwater organism within the quarry, which we were trying to prevent because there was a concern from the landowners about that as well.
Another aspect to the potassium that we liked was that we were really concerned about possibility for not getting adequate mixing, both because of inflow through fissures in the bottom of the quarry that might, or the sides that might have zebra mussels stuck back in them, or just the thermoclines that set up in the quarry. It's 100 feet deep, so you do get thermoclines at a certain time of the year. And so one aspect of potassium that really attracted us was the longevity of its effectiveness in the quarry. The original theory was that because we had very little flow through the quarry, that we might maintain lethal levels, chronically at least, for 20, 30 years. And as we've seen now, we're now 9 years later, and we still have very lethal levels of potassium in the quarry. So in effect, we've inoculated the quarry against future introductions, which would be very likely inadvertently by divers.
Thank you. Another question for all of you. Were any rapid response protocols developed upon conclusion of your efforts?
I won't say specifically as a result of the effort, but Virginia and the Mid-Atlantic panels and most of the panels around the country, where I think at this period of time we're talking about, remember this was over a decade ago, 10, 15 years ago, rapid assessment protocol development was kind of pretty well along in some areas, and people were just beginning to think about it in others. So I think there's been a lot of momentum in that regard, and we do have some rapid assessment protocols in the Mid-Atlantic and in Virginia as part of the Virginia Invasive Species Management Plan, but those things didn't exist, you know, back when we did this project.
Keegan or Brian, do you have any response?
From Tech's perspective, no, we don't have any developed at this point in time yet as a result of this tarping effort. In 2010, we had done a potassium chloride treatment as well on Citrus Grove Creek, and what I'm looking at is it'd be pretty difficult to write up a set of protocols for a because you really never have a good handle idea on when you might have a new introduction or someplace like this where you might want to try and do it. So set up a set of established protocols, it would be pretty difficult to do when you might be dealing with whether it be a small body of water, a cove within a larger reservoir, a flowing creek, or what you might be dealing with. So in my opinion, it'd be pretty difficult to have just a set of established protocols to follow.
This is Keegan from Minnesota. I would echo what Brian says. The Department of Natural Resources in Minnesota does have a response plan framework for general AIS for the state, but in terms of the application of that framework to each species, to each location, I think the importance of flexibility and agency cooperation is probably most important in terms of the development of a response plan, but also then being able to adapt it as conditions change.
I would agree.
I would agree as well.
Thank you. We did get one question early on regarding DNA sampling. It might be slightly beyond the scope of this particular webinar, so I'm going to ask it in a slightly different way. So I'm going to ask if you are you using DNA sampling or monitoring for Dreissena mussels? And if you are, did you use it in these efforts, and how was it used?
This is Brian Manzu with Texas Parks and Wildlife, and yes, we do utilize it both as a part of a monitoring program that we have, sampling lakes across the state. And yes, it was utilized within this treatment effort here on Lake Waco. We used it initially on Lake Waco. We were taking samples, again, helping us to try to identify whether or not this was truly an isolated location where we were finding the zebra mussels right there next to the boat ramp, or if they had in fact spread and they've been there longer than we maybe anticipated. Using it, we were not able to document any zebra mussel DNA or villagers anywhere else within the reservoir. And in fact, even at our initials there, we did not find any villagers in our water samples and that taken right there from the lake. And I think, again, I kind of alluded to it in my presentation. I really feel that was probably because if this boat was brought into Lake Waco in July, our water temperatures in July and August, September are usually in that 80 degrees higher levels, and that very likely probably helped us in keeping the zebra mussels from spawning, and that's probably why we didn't detect it right away.
This is Brian in Virginia. We don't use any DNA sampling. We don't have a specific sampling protocol for monitoring for zebra mussels since we don't have a current extant population within the state. It's more of education and outreach at this point, but it's something that we'll probably be talking about going forward with a couple bills in our General Assembly and a focus on monitoring some high-profile lakes, because we do some eDNA for detecting rare and endangered species. So it may be something that we look at in the future.
This is Keegan from Minnesota. eDNA is not used currently to monitor for zebra mussels. I know the University of Minnesota is doing some genetic work in terms of sequencing zebra mussel genome and potential use as a monitoring tool, but to date, we haven't seen any application of it.
Thank you. It looks like we have just 2 more questions. This is for Brian in Texas. What was the penalty placed on the marina that launched the infested barge?
The marina itself, there was no fines or penalties. They were not given any type of a citation. The citations went directly to the barge owner and operator, the crew that had come from Lake Belton for the vessel. I am not in law enforcement. I do not know exactly the amount of the fines that he ended up paying.
Thank you. And then one last question for today, and then we'll wrap up. In terms, and this might be directed more towards Ray, but if anyone can add insight, in follow-up to the question regarding the divers and movement of divers and travel out of state, folks are interested in trying to get a sense of the potential risk for spread of this as a pathway, and wanted to know if you know of any other quarries nationally that have been infested potentially due to recreational divers.
Yes, we do know some that have been potentially infested. I don't know of anywhere that have been prosecuted or proven. You know, it's a big step. We're a law enforcement agency as well, and because I worked with the law enforcement folks when they were pursuing this, but at the same time, I was trying to stay on the good side of the landowners and handle the eradication, so I didn't get too deep down inside into the investigation. There's a big step between suspecting that somebody planted rocks with zebra mussels on them, or brought some zebra mussels in on purpose, or in fact just brought them in a pocket in a you know, of a wet PC or BC, or a you know, in the felt of a wetsuit or something accidentally. There's a big step from suspecting something and proving it, and there have been instances in other states on the Mid-Atlantic, for example, where rocks not native to a particular lake or quarry or pit have been found with zebra mussels on them. And how did they get there? You know, it's kind of as I say, you can suspect it, but it's a big jump to trying to prove something. So I think there's definitely a threat of accidental, perfectly innocent, incidental transport in wetsuits or dive gear. When a diver might dive one side in the afternoon, pick up, clean his gear, just dunk his gear in the same water, and then travel overnight and dive another quarry the next morning. I think it would be very easy to have a transfer that way.
Thank you, Ray. So that concludes all the questions we have and all of our presentations. So I want to thank our presenters again, Brian, Ray, Brian, Keegan, and Kylie. Thank you very much for your presentations. Thank you to all of our participants and all those who asked questions. As a reminder, our webinar recording will be posted on our Invasive Mussel Collaborative website in the next few days. If you have any additional follow-up questions or comments, please feel free to contact us at the Great Lakes Commission. In addition, we encourage you again to join our listserv. If you have suggestions for future webinar topics, we welcome those as well. And with that, I will just say thank you one more time, and enjoy the rest of your day. Thank you.
Thank you, Erica.